Hello everyone, this is a Fab. We are going to explore a comprehensive history of thermodynamics. In this lecture, we are going to cover introduction of thermodynamics, thermodynamic systems. In thermodynamic systems, we will cover closed system, open system, isolated systems, and thermodynamic properties. In properties, we will cover extensive properties, intensive properties, and equilibrium and law of thermodynamics. Let's start from the introduction. Thermodynamics can be defined as a science of energy. Although everybody has feeling of what energy is, it is difficult to give a precise definition for it. Energy can be viewed as ability to cause the change. The name thermodynamics stems from the Greek words therm, heat, and dynamics, power, which is mostly descriptive of early effort to convert heat into power. Today, the same name is broadly interpreted to include all aspects of energy and energy transformations, including power generation, like refrigeration, relationships among the property of matter. One of the most fundamental law of nature is conservation of energy. It is simply states that during interaction, energy can be changed from one form to other form, but total amount of energy will remain same. Suppose an object at a certain height, if it will falling, its lose its potential energy into kinetic energy, but the energy of the system will remain same. Although the principle of thermodynamics have been existing since the creation of universe, thermodynamics did not emerge as science until the construction of first successful atmospheric steam engine in England by Thomson and Thomson Newman. These engines were very slow and inefficient, but they opened way for development of new science. The first and second law of thermodynamics emerged simultaneously. All activities in nature involve some interaction between energy and matter. Thus, it is hard to imagine an area that does not relate to thermodynamics in some manner. Therefore, developing a good understanding of basic principle of thermodynamics has long been an essential part of engineering education. Thermodynamics is commonly encountered in many engineering systems, all other aspects of life, and one does not need to go far away for seeing someone's application of it. In fact, one does not need to go away. The heart is constantly pumping blood to all parts of body. Various energy conservation occur in the trillion of body cells, and body heat generate constantly rejected to the environment. The human comfort is closely tied to the rate of this metabolic heat rejection. We will try to control this heat transfer rate by adjusting our clothes to the environmental conditions. Thermodynamic system. A system is defined as a quantity of matter or region in a space chosen for the study. In other words, we can say the space or area which have a definite boundaries surroundings surroundings where a thermodynamic principle or process take place is called system. The imaginary or real surface that separates the system from its surrounding is called boundary. The boundary of system can be fixed or movable. The boundary is contact surface shared by both system and surrounding. Mathematically speaking, boundary has zero thickness and it can neither contain any mass nor occupy any volume of space. Closed system or control mass. A closed system is a system which cannot transfer mass into the system or from the system, but it can transfer energy and work in form of energy in form of heat and work in form of like a rotatory or reciprocating motion of engine. There is no mass can enter or leave a closed system as shown in a figure, but energy in form of heat or work can cross the boundaries. And volume of the closed system does not have to be fixed. It is a special case. Energy is not allowed to cross boundaries. That special case is called isolated system. In isolated system, even crossing of energy is also prohibited. Here, another example of closed system is shown. Energy can not be transferred, or and energy can be transferred, but mass will remain same, consist of fixed amount of mass, and no mass can cross the boundary. It has fixed or rigid uh, bodies that not allow to cross mass of the system. Here we can see different systems shown in figure: open system, closed system, isolated system, and adiabatic system. Types of closed system. Here are two types of closed system. We have already seen in previous figure. A closed system, isolated system is a closed system which can not interact with surrounding by any means. Mean to say, it will not transfer heat or work uh, as previously we know that control closed system can transfer heat energy, but in isolate system, in this special case, the heat energy is prohibited to cross the boundaries. Similarly, rigid system. This is a system where mass of the system will remain constant, as well as volume of the system also remain constant, but only heat can be transferred in the rigid system. A closed or open system that does not exchange energy with the surrounding by means of heat is called adiabatic system. In adiabatic system, the heat cannot be exchanged with the surrounding. Open system or control volume. In this system, we can see that energy can be transferred as well as mass can be transferred, but volume of the energy, volume of the system will remain same. Properties of the system. Any characteristics of system is called properties. Some familiar properties are pressure, temperature, volume, and mass. These lists can be extended to include less familiar ones such as viscosity, thermal conductivity, modulus of elasticity, thermal expansion coefficient, electric resistivity, and even velocity and elevation. Intensive properties. The properties of the system whose value for entire system is not equal to the sum of their values for individual parts of the system are called extensive properties. For example, temperature, pressure, density of the system are intensive properties. If we take an example of pressure, temperature, suppose from the room we will take a sample of temperature from any corner of the room that will represent the entire temperature of the system. Similarly, uh, we will take a drop of water from glass of water. It will represent entire density of that glass of water. Similarly, concentration, melting points also follow same principles. These properties do not depend upon the mass or size. Extensive properties, the the properties of the system whose value for entire system is equal to sum of their values for individual parts of the system are called extensive properties. For example, total volume, total mass, total energy, or all type of energy uh, included in extensive properties, except expect except only specific properties. Where specific from appear, it will donate extensive properties. Equilibrium. Consider consider a system not undergoing any change. At this point, all properties can be assumed or can be calculated throughout the system, which give us a set of properties that completely describe the condition of the state of the system. Thermodynamics deals with the equilibrium states. The word equilibrium implies state of balance. In an equilibrium state, there is no unbalanced potential or driving force within the system, and a system in equilibrium experiences no change when it is isolated from the surroundings. There are many types of equilibrium, and a system is not in equilibrium unless condition of relevant types of equilibrium are not satisfied. For example, a system is in thermal equilibrium if temperature of the system throughout the entire system does not change and will remain unchanged. It is known as a thermal equilibrium. The mechanical equilibrium, it is related to pressure, and a system is in mechanical equilibrium if there is no change in pressure at any point of the system with time. However, the pressure may vary within the system, which elevation elevation as a result of gravitational effects. For example, higher pressure at a bottom layer is balanced by extra weight is must carry, and therefore there is no imbalance of the force. The variation of pressure as a result of gravity the most thermodynamic properties of the system is relatively small and usually disregarded. If system involve two phase, it is in phase equilibrium when mass of the each phase reach an equilibrium level and stay there. Finally, a system in a chemical equilibrium if chemical composition does not change with time, that is no chemical reaction occur, a system will not be equilibrium unless all relevant equilibrium criteria are satisfied. There are three major laws of thermodynamics. First law about conservation of energy. In this law, it states that energy cannot be destroyed or cannot be created. So it can be transferred from one form to another form. According to this law, the energy due to heat supplied must be balanced by external work and plus the gain internal energy due to rise temperature. It also states that the definite amount of heat needed to produce a definite amount of mechanical work, vice versa. Second law of thermodynamics. This law states that there is a definite limit to amount of mechanical energy which can be obtained from given quantity of heat energy. This law is supported by Celsius and Calvin Planck. According to Celsius, this law may be stated it is impossible for self-active machine working in a cyclic process not transfer heat from a body at a lower temperature to a body at higher temperature without aid of external agency or external work. The second law of thermodynamics has been stated by the Calvin Planck. It is impossible to construct an engine working on a cyclic process whose sole purpose is to convert heat energy in the work. According to this statement, second law of thermodynamics is sometimes called a law of degradation of energy. Third law is all about entropy of the system. The third law of the thermodynamics states that the system as the temperature of approach zero in a system. It is said that once temperature is reached at 0 Kelvin, the disorder of entropy or distance between molecular of the substance reach zero. There is no distance between the molecules. Entropy is defined as quantitative measure of disorder of random or randomness in the system. This was all about the today's lecture. Hopefully we will try my level best. I will try my level best in next lecture to cover all aspects of thermodynamics in detail. And this is my first approach to deliver the lecture. Hopefully you will like this lecture. Yeah, thank you for watching the video. Goodbye.